How long do you want to stay around, Explorer 1? Indeed, the old probe has revived and once again proven that, despite all the confusion, it remains a reliable outpost in the mysterious world of interstellar space. This was preceded by an event that has almost become part of NASA's daily routine. Specialists had lost contact with Explorer 1 due to technical issues, and this was not the first time they had to get creative to re-establish communication with the aging spacecraft. In the end, the path to success came through a component that had actually been obsolete for decades. Yet, the emergency transmitter, which hadn't been used since 1981, worked as expected, allowing the space veterans to call home again. When it's cold outside, it's a good idea to turn on the heating. So far, so obvious. But things get complicated when it comes to increasing the temperature in the depths of interstellar space. And on a spacecraft that has been journeying through space for nearly 50 years, which has repeatedly attracted attention for its technical problems. What should have been a routine task once again turned into an unexpected issue for Explorer 1. After NASA specialists had ordered the probe to activate one of its radiators on October 16, they discovered, to their perplexity, 2 days later, that the Deep Space Network could no longer detect the Explorer 1 signal. The fact that researchers had to wait 46 hours before this troubling realization reached them is once again due to the immense distance between Explorer 1 and our home planet. Specifically, since 1977, the probe has been separated from Earth by about 24.7 billion kilometers, and it takes nearly 23 hours for a message to cover this enormous distance. The same amount of time is therefore also estimated for the response. But what actually happened? Well, Explorer 1 is equipped with an onboard error protection system that reacts autonomously when a problem arises. This is the case, for example, when the spacecraft's power supply is overloaded and the error protection system shuts down non-essential systems to save energy. However, apparently, the heating command also triggered the error protection system, even though Explorer 1 had enough power to activate this component. For a better understanding, it's worth mentioning briefly at this point that Explorer 1 normally communicates with Earth via a radio transmitter in the X-band, named after its specific frequency. Following the loss of contact, specialists reasonably assumed that the error protection system had reduced the rate at which the corresponding transmitter was sending data. This is not surprising, as this mode consumes less energy. Unfortunately, this also alters the X-band signal that the Deep Space Network must search for. Fortunately, NASA engineers were able to identify the desired signal on October 18. Even though Explorer 1 seemed to be in a stable state aside from this, the next issue soon emerged. How did a 40-year-old backup transmitter help NASA out of a jam? The following day, communication with Explorer 1 completely stopped. The flight team suspected that the error protection system had triggered again, possibly turning off the X-band transmitter and switching instead to a second radio transmitter, the S-band one. However, this was actually retired from service long ago. Although the S-band consumes less energy than the X-band, Explorer 1 hadn't used it to exchange messages with Earth since 1981. To put that year into historical context, that was the same year that U.S. President Ronald Reagan and Pope John Paul II were both seriously wounded in assassination attempts, and Prince Charles married Diana Spencer. Returning to the present, it's clear why the S-band had been obsolete for 43 years. Despite its energy-saving advantages, it uses a different frequency than the X-band transmitter and thus emits a much weaker signal. Given the immense distance, NASA specialists weren't initially sure they'd be able to detect the S-band. But they found it and had to decide on the next course of action. However, given the history with the error protection system, simply switching the X-band back on seemed too risky. This should only be done once the cause of the system's triggering was clearly identified. However, past experience had shown that such an error investigation could take weeks or even months. Does this mean that contact with Explorer 1 would also be lost during that time? Fortunately, no. There remained the S-band backup. On October 22nd, specialists sent a command to check if it was working correctly. And presto! On October 24th, they received the reassuring response that a stable connection had been re-established. It turns out that the NASA backup transmitter, which hadn't been used for over 40 years, was now successfully maintaining contact with the most distant outpost of humanity. But despite all the success of the S-band transmitter, it's also undeniable that the journey to the edges of the solar system has taken its toll on the spacecraft's instruments, and we may need to slowly but surely come to terms with the idea that even the longest success stories in space exploration will eventually come to an end. The Voyager mission is prolonged, but there are challenges ahead. However, it's also true that the Voyager mission members must sometimes come up with creative arrangements to regularly extend the operations of their sister spacecraft, which is identical in design. But no one could have predicted back in 1977 that things would come to this point. When the Voyager probes were launched into the vastness of space, the mission was originally planned to last just 5 years. The fact that these spacecraft have now exceeded expectations by nearly 10 times is partly due to the fact that they have been subjected to a strict energy regimen. In other words, in order to conserve energy from the aging radioisotope batteries, NASA has systematically powered down additional instruments. For example, the plasma sensor on Explorer 2 was deactivated just a few weeks ago to allow the remaining instruments to continue operating for several more years. However, this energy-saving plan is becoming increasingly delicate whenever an unexpected event occurs. For instance, if an essential valve fails, it could lead to a situation where the engineers decide to stop using the valve and let it go. But what happened then? Well, for the explorers to be able to point their antennas toward Earth and phone home, they need to adjust them using small positioning thrusters. These thrusters, powered by liquid hydrazine, adjust the alignment in several small bursts that only last a few milliseconds. Explorer 1 originally had 3 sets of small thrusters, but with decades in space, fuel deposits have built up in the fuel lines. NASA was forced to switch from the first to the second set of thrusters 22 years ago. In 2018, they finally switched to the third set, which was actually intended for trajectory correction. Unfortunately, this set has also recently drawn attention due to what's called clogging. In fact, the situation is now more serious than before, as the diameter of the thruster's fuel lines has decreased from 0.25 millimeters to just 0.035 millimeters, less than half the width of a human hair. Before the components fail completely, specialists decided to revert to one of the previous, less worn-out sets of thrusters. But this isn't as easy as it sounds. Since Explorer 1 has almost no energy left, any extra energy consumption could mean the failure of a key system. That's where the problem lies. For the alternative set of thrusters to be reactivated, they must be preheated. But due to the depletion of energy reserves, this becomes increasingly difficult, indispensable for complicating things. The scientific instruments were at risk of not turning back on once they had been switched off. This is how NASA scientists first withdrew for weeks to focus on their calculations and tests. After this stage of the conference, it was concluded once again that the extinction of one of the main heating units of Voyager 1 posed the least risk. On August 27th, the second unit had arrived, and NASA performed its risky maneuver to change it, ultimately being rewarded for their mental fortitude. If the main heating unit had been shut down for an hour, the nozzles would have heated up during that time, allowing Voyager 1 to aim towards Earth once again, at least for now. As we mentioned, this equipment is also a promotion, except for a rather old story of a clogged pipe. At a certain point, no matter how refined the transportation adjustments may be, they will no longer be of any use, because even if Voyager 1's antenna is still pointing towards Earth, experts assume that radio contact will be lost at the latest by 2036 due to the ever-increasing distance. Our experts suppose that the standard contact will be lost in the coming moments, due to the increasingly reduced distance separating you from the subscription button. So go ahead and click the subscription button now so you never miss a new video from us. See you soon.